Hello dear, how are you all? Today in this video we are going to discuss about very famous topic of calculus. Knowledge of calculus cannot be completed without this. Even we can't check the continuity of any function without this. Yes, you must have understood that we are talking about limit. What is limit? Why do we need limit? Why limit is important in calculus? You will get answer to all these. Stay connected with me till the end in this video. We will come to the point. You know what is continuity of a function? If there is no breakup throughout the graph of the function and function is defined at each of the point in given interval, we say function is continuous. There is no need to find the limit of function if function is continuous and defined at each point. For example, suppose we have a function f of x is equal to 2x. You know, for each x belong to set of real number, function is defined. Hence, there is no need to find the limit at any point. There is no need to find the limit at any point because function is continuous at each of the point. We just find the limit of function when function is not defined at any point. Since function cannot give the value at a point on which function is not defined, we have a suspense what will be the value of function at that point. Now question is this: how can we find the value of a function at a point on which function is not defined? For the same purpose, we find limit of function. Suppose if we have a curve, our function f of x is equal to x square minus 9 over x minus 3. You see, when we take x equal to 3, function becomes undefined, and we cannot find the value of function at x is equal to 3. Now, how can we find the value of function at x is equal to 3? For the same purpose, we find the limit of function. We have a function f of x square minus 9 by x minus 3. At point x is equal to 3, function becomes undefined. But we want to find the value of function at x is equal to 3. Since function is not defined at x is equal to 3, how can we find the value of function at x is equal to 3? We apply a process here by which we find the value of function at x is equal to 3. We approaches to 3 from both sides. We just have to estimate if 3 is a point somewhere in the interval of function, then what will be the value of function at x is equal to 3. We just have to estimate if 3 is a point somewhere in the interval of function, then what will be the value of function at x is equal to 3. We take 2 points. One from left of 3, which is 2, and other which is right of 3, which is 4. You see, as we get closer and closer to 3 from both sides, you see, as we get closer and closer to 3, the function value also gets closer and closer to 6. I mean to say, as we get closer and closer to 3 from both sides, you see, first we take 2, then 2.5, 2.9. We are going to try to approach 3 from both sides. You see, function value also gets closer and closer to 6. It appears from this table, as x approaches to 3, f of x approaches to 6. You see, as x approaches to 3 from this table, f of x approaches to 6. That is, if we choose x close enough to 3, that is if we choose x close enough to 3, we can force f of x to be as close to 6 as we wish. If we choose x close enough to 3, we can force f of x to be as close to 6 as we wish. From this we conclude that 6 is the limit of function as x approaches to 3. I would like to explain it again. When we take x into 4, function value is 7. When we take x 3.5, function value is 6.5, and so on 3.1, function value is 6.1. When 3.01, function value is 6.01. When x 3.001, function value is 6.001, which is closest to 6. And when x is equal to 3.001, function value is 6.0001, which is closest to 6. You see, when we approaches to 3 from greater value of 3 toward 3, when we approaches to 3 from the greater value of 3, the function value continuously decreases and try to become closest to 6. Similarly, from left side, when we approaches to 2 from lower value, when we approaches to 3 from smaller value of 3, 2, 2.5, 2.9, which is we are going to reach at toward 3. You see, function value continuously increases and try to become closest to 6. From this we conclude that 6 is the function value as x approaches to 6. We can't put x into 3 in a function direct. We just have to imagine what will be the value of function as x approaches to 3, what will be value of function. So by using the symbol, we can write the result. F of x approaches to 6 as x approaches to 3, or limit x approaches 3 of f of x will be equal to 6. Limit is equal to 6. In general, if f of x approaches to L as x approaches to C, we say that L is the limiting value of function as x approaches to C, and we can write it as limit x approaches to C, f of x will be equal to L. We write L is the limiting value of f of x when x approaches to C. This is the simple concept of limit. Thank you.